In this video, we're going to look at hypothesis testing for two means, but we're going to be using dependent samples, which is also known as matched pairs. We're going to be using StatCrunch to do this. If you have not watched the basics of hypothesis testing videos yet, or any of the other proportions videos or means videos that I've made, you will want to go back and do that before you watch this one, because there's some foundational information in those that you will need to have. Now, our difference between independent and dependent samples, because our test that we're doing in this video is only for dependent samples. So an independent sample means that our groups that we are picking, they are not related to each other. So if I were to compare the IQ scores of men to women and there was no connection between the men that got selected and the women that got selected, that would be independent sampling. Now, dependent samples, if I did IQ scores of a brother compared to the sister, that would be a dependent sample because there's a natural connection between those pairs that are being selected. So in this particular video, we are only doing dependent samples. Now, our requirements in order to do this, well, we have to have dependent samples and they need to be simple random samples. And then we also need to make sure that our number of pairs is either larger than 30, so we can use the central limit theorem, or that the pairs of values are from normally distributed populations. Once we have that, we can go ahead and do our null hypothesis. Now notice our notation here. It says mu sub d. That stands for the population mean of the differences. That's what the d stands for there. Now when it talks about these differences, if we were doing IQ scores, and let's say for one particular pair, the brother had an IQ score of 105, and the sister had an IQ score also of 105. Well, when we're looking at the differences, that means how far apart are they? So we would do subtraction here, and our differences from 105 to 105 would be 0. So what we're testing is the mean of all the differences equal to 0? Because that would imply that there's no difference between our groups. Now, our alternative hypothesis can take our three forms that we have previously talked about. We can either have not equal to 0, we can have that the mean of the differences is less than 0, or that it's greater than 0. And that choice depends on the context of the problem that you're working in. So once we get our null and our alternative hypothesis set up, that takes us then to our test statistic. So for this one, we would be doing a t-test. When we have dependent pairs, it's always going to be a t-test for what we do. And we have some slightly different notation again. So d bar here is very similar to our x bar, where we are going to be working with a sample mean, but in this case, since it is a bar is over the d, we're going to be working with the sample mean of the differences. So what this would look like is, let's say we were doing IQ scores, and we had all of our different partners here, the different pairs. Oops. So that's 108 and 100. We would have to make another column of the differences, so we would subtract our values. Now, the order that you subtract them in will kind of depend on the problem. If it's a before and after type of test, like a pre-test and a post-test, you would want to take the later value minus the original value. If it's just two groups, then the order that we subtract them doesn't matter, as long as we keep straight in our head which one was group 1 and which one was group 2. So in this case, like our first difference, we would have a 0, our next difference we would have a 9, our next difference we would have an 8, and we would continue to do this for all of them. So we would get with this column of differences over here. And then we would find the mean of our differences, and that's the value that would go here. Now, our mu sub d, well, our null hypothesis said that that was going to be equal to 0. And then S sub d, that is our sample standard deviation of the differences. So we would come back to our differences, our column of differences here, and then we would have to find the standard deviation of that column. And that's the value that we would put in here. And then our n is our sample size. Once we get our test statistic, for this particular test, our degrees of freedom is our sample size -1. From that point, you would then need to choose, are you going to use the critical value method or the p-value method, which I'm not going to go through again because I've done that multiple times in those other videos. So in this example, we want to find out if the ACT prep course does increase ACT scores. So 32 students took the ACT before and after taking an ACT prep course. Their before and after scores are shown in StatCrunch. I'll pull that up in just a second. And we want to test the claim at the 0.05 significance level that the ACT Preps class raises ACT scores. Now, the reason I'm doing this entire problem in StatCrunch instead of writing it all out by hand is because we would have to take all 32 scores, or 32 pairs. We would have to find their column of differences. And then once we find those column of differences, we would need to take the mean of that column, and then we would also need to find the standard deviation of that column. Once we would have those two values, then we could go back in and we could do our test statistic and hand compute it. That, it's just going to take a long time to do with these 32 scores, especially hand computing the standard deviation. So I'm just going to show you how to do this directly in StatCrunch. Once we get into StatCrunch, we would go to Stat, T-Stats, and then Paired. Notice you do not select two samples here. Okay, you select Paired, which is the third option on the list. If you were to select two samples, that would imply that we had independent samples, and we do not have that in this situation. We have dependent because we have before and afters. Take note that you do have to enter the raw data into StatCrunch to do a matched pair test. Okay, so keep that in mind. All right, so here's our data set in StatCrunch here. You can see I have my 32 before and after scores listed. Now, if we wanted to do this computation by hand, we would need to make another column here of differences. Now with before and after, I want to make sure that I take my later one minus my original one. That way my sign, whether it's positive or negative, corresponds to an increase or a decrease. So for instance, I'm just going to do a couple. I would take the 24 minus the 21 and have a difference of 3. And then I would take 25 minus 24 and have a difference of 1. 20 minus 17 is a difference of 3. 20 minus 19 would give me a difference of 1. 25 minus 27 would give me a difference of -2. And I would keep going and do all of those values. Now I'm not going to do that because it's going to take too long. But once I did that, then I could come in here to Stat, do my summary stats in a column. I could select my differences, have it compute the mean in the standard deviation, and then I could use those values to do my hand computation for my test statistic if I needed to. Now keep in mind, these values right now are not accurate because I didn't do my entire list of values, but that's just the process if you needed to do it by hand that you could use to do that. What I'm going to show you is how we can have StatCrunch do the entire problem for us. So we're going to go into this Stat menu, and then we are going to come down here to T-Stats. And again, this right here is where you need to choose Paired. Do not go into the 2 sample one because that implies that we had independent samples, and that's not the case. We had dependent one. We had paired samples. So make sure you select the Paired option. And now here it tells us that sample 1 is in and then sample 2 is in. Well, when we have before and after, our sample 1 is actually our after score. Our sample 2 is our before score. Okay, and then if you want to see the differences, you can select this box and it would do an entire column of differences for you if you need to see that. So I guess you wouldn't have to hand compute them all. We want to come down here, we want to perform a hypothesis test for the differences, and mu sub d is equal to 0. That's not going to change, but what we do need to check is to make sure our alternative hypothesis matches whatever our problem was asking for. Now, the question that we were working with said, did taking the test increase their scores? So we are looking, was the difference larger than 0, because a value larger than 0, since we're doing after minus before, would indicate that it has increased. So that's what we are testing for. Then we can go ahead and do compute, and notice our output table gives us our test statistic right here and gives us our p-value right here. And then from here, you could select whether you wanted to do the critical value method or the p-value method. I would choose the p-value method because we have our p-value right here. So with this situation, our alpha was 0.05, I believe. And now remember, our phrase is if the p is low, the null must go. Well, since our p-value of 0.0034 is less than our significance level of 0.05, then that's an indication that our null hypothesis can be rejected. So we would reject our null hypothesis, which says that there's no difference in the scores, and we would then say that we have sufficient evidence to support the alternative hypothesis that the difference in the scores is larger than 0. So basically what that's saying is that based off of our sample, it looks like the ACT test prep course for these students did indeed increase their scores because the difference was larger than 0. Okay, so that's how you can work in here with StatCrunch to do that problem a little bit more quickly.